students, today we are going to start our chapter area related to circles. In this chapter we will find out the areas of the different geometric figures. So let's start. First of all, we have to know the area of the combined figures. How to find the area of combined figures? In this module we will learn about the area of combination of plane figures. In our daily life, we may have come across the various interesting designs such as this is the basketball court, this one is the map of a house, and this is the bed sheet design. In all these three examples, we observe there are different basic shapes such as rectangle, square, semicircle, circle, pentagon, like this. So, we will learn how to find the area of these types of combined figures. Let us take an example. There is a window and we have to decorate this window and we want to make a curtain for this window. So how much curtain we need? For finding this, we have to find what is the total area of this window. Now consider this window again. Look at this window. This window is nothing but the combination of two figures. So this window we have to divide into two basic shapes such as first upper part, that is the semicircle, and the down part, that is a rectangle, or we can say a square. So what we have to do? We have to find the area of the both basic shapes separately, and then we will add the areas of the two shapes to get the required area of the curtain. So we can say the area of the curtain of this window, that is equals to area of this semicircle plus area of the rectangle. So in this way we have to find out the areas of the combined shape, that is whatever the shape is there, we have to consider that shape, or we have to divide that shape into two or more than two basic shapes, and by finding the areas of different shapes, and when we add the areas of different shapes, we get the complete area of the combined figure. So let's take the problems of exercise 12.3. Here the question number 1 says, find the area of the shaded region in the figure 12.19 if PQ is equals to 24 cm, PR is equals to 7 cm, and O is the center of the circle. So here this figure is given. We have to given this PQR is a triangle, and two sides of this triangle is 7 and 24 cm respectively, and its center is O. So here when we have to find the area of the shaded portion, this is the segment QP, or here we can say our point is there. So this shaded portion and this shaded portion, we have to find the area of these two parts. So that is equals to the area of this semicircle when we find and subtract the area of this triangle. So we get the area of the shaded portion. So for this we have to find the area of this and the semicircle. So first of all, let's find the area of the triangle. Now here this RP is the diameter. So we know the RP is the diameter, that circle divided into two semicircles, and also we have the angle in the semicircle are 90 degree, that is the angle P is 90 degree. So here this triangle PQR is a right angle triangle. So we can use the area of the triangle PQPR, that is equals to half into base into height, that is equals to half into PR into QP is equals to half into 7 into 24, and when we simplify this by cancelling 2 and this 24 by 12, so next step we get that is equals to 7 into 12, 84 centimeters square is the area of this triangle. Now we have to find the area of the semicircle. So for area of semicircle, as we know that semicircle, that is half of the circle. So area of semicircle is half of the area of the circle. So here, for finding the area of this semicircle, we need to know what is the length of this diameter. So by using the Pythagoras theorem, we can find it out. QR, that is equals to hypotenuse, is equals to QP square, that is perpendicular square, plus PR, that is base square. So by putting the values, 24 square plus 7 square is 576 plus 49, we get QR square is 25 centimeter. QR square is 625 and QR, that is diameter, is 25 centimeter. Now, as we have the length of the diameter is 25 centimeter, so its radius is half of the diameter, that is 12.5 centimeter. Now why we are finding the radius? As we know that the area of circle is pi r square, so we need the radius. So by using the Pythagoras theorem, we get the radius of the circle is 12.5 centimeter. Now easily we can find out the area of the semicircle, that is equals to half into area of circle and half into pi r square, or we can say 1 by 2 into 3.14 into 12.5 square. So this can be written as 1 by 2 into 3.14 into 12.5 into 12.5. 12.5 we can cancel out this by 2 6 are 12, 2 2s are 4 and 2 5s are 10. So we get 3.14 into 12.5 into 6.25, and product of this we get area of semicircle is 245.312 centimeters square. Now easily we can find out the area of the shaded portion, that is area of semicircle minus area of triangle, and it is equals to 245.3125 minus 84, that is 161.31, or we can say area of this shaded part is 161.31 centimeters square. Now let's take one more problem, problem number 2 of this same exercise. Find the area of the shaded region in the given figure if the radii of the two concentric circles with center O are 7 cm and 14 cm, and angle AOC is given 40 degree. So here, as we know that the circle having the same center are known as the concentric circles. So here OB, this is the small r, so we can write it as the small r is 7 centimeter, and this OC, this radius is denoted by the capital R, so it is given 14 centimeter. Now we have to find this shaded part ABDC. So as we observe here, when we know the area of this AOC, now area of AOC, that is area of sector AOC, and from this area of sector AOC we subtract the area of sector BOD, we get the area of this shaded part ABDC. So let's start the solution. Area of shaded region is area of sector OACO minus area of sector OBDO, and we know that the area of the sector is theta upon 360 into pi r square, and where we have to given this angle is central angle is 40 degree. So put the value 40 degree. So area of the shaded region, that is equals to 40 degree upon 360 degree into pi capital R square minus 40 upon 360 degree pi into small r square. So we get here, after cancelling this 4 9s are 36, this is again, and here also 40 1s are 40 and 40 9s are, we can say. So 1 by 9 we take common, and pi is also common. So 1 by 9 pi is the common in both the terms. We get 14 square minus 7 square, or 14 square minus 7 square. We can write a square minus b square, that is a minus b and a plus b. So 1 by 9 into 22/7 pi is, we are taking 22/7 into 14 minus 7 into 14 plus 7. Then we get the product of all these terms is 51.33 centimeter. So we can say area of the shaded region is 51.33 centimeter square. So these steps, when we further simplify, we get this 51.33 centimeter square.